Until recently, transportation engineers favored private cars for urban transport planning. This has caused a great damage to both human health and to global warming. As is well known, the preference for cars does not solve traffic problems, but generates more traffic. This is why more and more places around the world are beginning to favor pedestrians, cyclists, and public transport. With smart urban planning, we could push back the dominance of private cars and create a livable environment for ourselves and for our children. One of the methods for that goal is to prioritize public transport where it is possible. The best solution is to build underground metro systems and new tramlines, but they are expensive and take a long time to build them. Until then, we can open new bus lanes and prioritize bus traffic where we can. An intermediate solution where private car traffic is significant is to reprogramming traffic lights to prioritize public transport, like at the Grand Boulevard with the tramline 4-6. In this homework, we did this in a smaller scale and with buses. The conception of the task is to prioritize buses at the traffic lights. When a bus arrives at the intersection, the lights switch to another traffic light program, through which buses and vehicles on the main road will wait less at the red light, or in some cases they have no red time at all. The Sumo environment is a 1 kilometer long road stretch with 5 intersections. The main road has 2 lanes on each side, and the crossroads are 2 times 1 lanes each. All of the traffic lights have the same 90 seconds long program and an offset for starting at different time steps. First, 39 seconds of green time for the main road, then 3 seconds of yellow time for the main road 2, then 3 seconds of red-yellow time for the crossroads, 39 seconds of green for the crossroads, 3 seconds of yellow for the crossroads, and then 3 seconds of red-yellow for the main roads. As you can see, this traffic light program makes the buses wait at the red light for a long time. Back in the old days, the solution for this problem was that bus drivers knew the exact traffic light program. They knew the optimal speed between intersections to have a green wave, so they use less diesel fuel. But this is not a perfect solution. In the modern times, drivers are stressful and learning traffic light programs are not their priority. The city is changing constantly, and so are traffic light programs. And even if they were constant, the traffic and the passengers are not the same every time. So a solution to this could be altering the traffic light programs. The simulation has 4 pairs of bus stops. The second and the fourth are at the middle of the road segment. The first pair of bus stops are at the first intersection. Both of them are after the intersection, like the bus stops of the line 53 at the Kosztolányi Dezső Square, and the third pair are left to the intersection, like the stops of the bus line 7 at Astoria. The simulation has 4 induction loop detectors too to detect buses. The first and the second pair are 50 meters before the intersection to give the traffic lights enough time to adjust. At the third intersection, one of the detectors is 50 meters away from the crossroads, but the other one is right after the bus stop because of the position of the particular bus stop. The fourth pair of detectors are 50 meters away from the fourth and fifth intersections because of the bounded operations of the traffic lights. The Python program for the trace interface consists of 2 files, a main file and a traffic light.python file. The latter file just consists of a class for the traffic lights with variables and functions. The traffic lights file has a lot of variables that we will use later, for example, offset of the traffic light, last time step when a phase change occurred, additional green time that defines that after a bus is detected and given green, how long that green time should last, etc. We have 3 functions. The starter starts the traffic light program when the time step equals the offset. The switch to priority function defines what the traffic light should do between the time step of detecting the bus by the inductive loop and the time step when the additional green time ends based on the phase of the traffic light at the time step of the detecting. The switch to intermediate function defines what the traffic light should do after the additional green time ends and how to switch back to the original traffic light program. In the switch to priority function, we consider multiple cases. If the traffic light was yellow for the main road or red-yellow for the crossroads, we couldn't just switch to green or red-yellow for the main road. In this case, we give a minimal green time for the crossroads, then give green for the main road and call the switch to intermediate function. If the traffic light was red-yellow for the main road, or yellow for the crossroads, or green for the crossroads, but the remaining green time is a few seconds, then we do nothing. The bus would get green very soon. If the traffic light was green for the main road, we just leave the lights green, and after the end of the additional green time, we call the switch to intermediate function. In the switch to intermediate function, we consider multiple cases too. If the additional green time ends while the traffic light is still green for the main road, then we leave the lights as they are, and when the original traffic light program would change phase to yellow for the main road, we switch back to the original program. If the additional green time ends while the traffic light would be yellow, or red by the original program, and less than 11 seconds would be remaining from the red time, then we aren't switching back to the original program for that few seconds. Instead, we are waiting for the time step when the original program would give green for the main road and switch back to the original this time step. If more than 11 seconds would remain from the red time, thus more than 5 seconds would remain from the crossroads green time, then we switch to the main road's lights to yellow, after that the crossroads light to red-yellow, then green. We switch to our original program at the time step when the crossroads would get yellow. In the main file, we evaluate these functions when they are needed. The switch to priority function is triggered if a bus is detected by the loop, and the switch to intermediate function is called when a variable is set true by the switch to priority function. Note that to switch to priority function does not always set this boolean true. The results are promising. With the altered traffic light program, the buses cover the route faster and more efficiently. We tested our program in two scenarios. In the first one, the passenger vehicle traffic flow from one end to the other end of the main road is 400 vehicles per hour, and the traffic flow that starts the route from one of the crossroads is 80 vehicles per hour in each crossroad. In the second case, these numbers are 800 vehicles per hour and 120 vehicles per hour. The effects of the altered traffic light programs are above our expectations. In the first case, the average travel time on this 1 km long section decreased from 270 seconds to 211 seconds. This is almost a minute and almost 22% less than before. The average speed increased from 13 km per hour to 17 km per hour, and the combined fuel consumption of all buses on this section decreased from 49 liters per hour to 44 liters per hour. This means 5 liters of diesel fuel are saved on each hour on this kilometer. Assumed 12 hours of bus traffic on this line every day, this means more than 20,000 liters a year, which reduced the transport company's cost by more than 16 million forints, or more than 10 million forints calculated with the government-mandated price cap. This project could be improved furthermore with a few considerations. In our homework, we only considered one possible scenario in each aspect. We could try another layout, or maybe we could use some bus lanes so we could further improve our results. The other point where this homework could be improved is the default traffic light program. We consider the simplest case when the green time for the main road and the crossroads are the same, but in the real world, the main road green time is often longer. With this change, our result could be a bit less impressive. Thank you for your attention, and a big thank you for Baross Rádió to provide a studio to record my audio file.